Well, hello again, and welcome to my workshop. Yes, this really is my workshop. And you may wonder what I'm doing in a darkened workshop with one lit candle. No jokes, please. The story behind it is quite interesting. The other day at a repair workshop, I was given a very high power 2 million candle power search torch, one of these big yellow torches. And it belonged to a lady whose father used to use it, and since he passed away, it's been put in a cupboard and not used for many years. And she pulled it out the other day and thought it'd be nice to use it, but obviously when she turned it on, nothing really worked on it. Now, it's a rechargeable type torch with a lead acid battery fitted to it, and these batteries are notorious, if they're left to discharge completely and not used for many years, to fail. So this torch was not working. But we didn't know it was a battery at that time. And I thought it would be a good idea to use this as an example of fault finding for my grandson, who's doing a Duke of Edinburgh award, and part of that is to diagnose and find problems on different pieces of equipment. Anyway, that's the backstory, and this video is going to be about luminosity, lumens, and candle power. So let's start off with a little bit about candle power. So at the moment I'm being illuminated by the light of one candle. There's a little bit of stray light coming in from other places. But one candle power is the amount of light that one candle produces in 1 square foot, which is 1 foot from the candle. And that light is measured in lumens, and it's 12.57 lumens. So one candle power is equal to 12.57 lumens. All this will become a little bit clearer a little bit later on. So why do we have torches and lanterns using candle power as a measurement instead of lumens? Well, there are two different forms of light. A candle power is usually used in high power spotlights in theatres and things like that, and also these big high power torches used in rescue and finding things. And the reason for that is that candle power is an intense form of light in a specific area, whereas lumens are used to measure lights in, say, a big hall where you want a wide area of lighting, and they're measured in lumens, whereas these torches are measured in candle power. I hope all this is becoming so confusing you're going to give up at this stage, but please hang in there, because we're now going to move over to the torch itself, have a look at it and try and find what the problem is. So let's do that. Well, this is the torch in question. It's named a Mission, and it's got a 2 million candle power output from it. It's powered by a 6 volt 4 ampere hour battery, and it has an intense beam which is provided by a halogen bulb, and halogen bulb as opposed to LEDs, which new ones might be powered by, so it gives you an idea of its age. It has an input for an AC supply adapter at 6 volts, and it also has an on and off switch, adjustable handle, and that's about it for controls. So let's have a closer look at what's inside this torch and draw out the circuit diagram and see if it's fairly obvious or not what the problem with it is. So let me go through the fault finding with you now on this torch. Well, I've stripped the torch down because it was fairly tedious showing you how that happened. But basically the torch is stripped down. The module you can see in front of you is a little control module, and you'll see the bulb housing, the reflector, the lead acid battery, and the charger, and lots of my scribbling notes there, because I had to try and work out exactly what was going on in that little module. And So let's have a look at that and see exactly why this torch isn't working. So here we are at the bench, and the torch now completely empty, as you can see. Bits left on it are the plastic switch and the charging socket receptacle. Okay, so that's the torch. So stripped it out, and it wasn't too difficult to strip out, but let's start with the bulb housing. The top is easily removed, and that just clips off from there. That was easy. And then the halogen bulb is situated just here, and you remove those clips, and it's a standard halogen bulb fitted into this unit. And I've checked that with a meter, or we've checked it with a meter, and that was fine. Next up is the housing, and this consists of a plastic molding and a switch, a very rudimentary switch here, which is activated by the control on the top, and into that slots this little control panel. And the control panel, the control circuit board, has a number of connections to it. It has the switch, positive switch connection to there, and that goes on to the side of the bulb housing to give the negative return. It has two negative terminals. It has a positive terminal and a fuse, inline fuse, and that goes to the battery, and the other one of these goes to the negative, the battery. The nerve center of the whole thing is this cute little module here. I'm going to give you a close-up of that so you can see it in a little bit more detail. But the main challenge for finding the problem with this was what was going on in this. Now that little box there is a relay. It's a changeover relay, and it took me a little while to actually figure out what the circuit was on that. I'll put a photo up now so you can see. It's not overly complicated, but it just took a little bit of figuring out. And what happens is basically when the torch isn't on charge, and here's the charger here. It's an AC/DC adapter, 240 volt, 230, 240 volt input, and the output is 6 volts at 300 milliamps, 1.5 VA. So that's it. That's that, and I've checked that out, or we've checked that out, and that's absolutely fine, giving 7 volts offload coming out of there. So that's okay. This little module does two things. First of all, it controls it doesn't control. It gives the charging current to this this battery, which is a John Light 6 volt 4 ampere hour. 20 ampere hour lead acid battery, sealed. And that one, by the way, is absolutely flat. Well, it had 1.5 volts on it, so that gives us a clue about what's wrong with this. We checked a continuity check on the fuse, found it was okay, and continuity checks through the relay found that was all right. So basically, we come down to the fact that the battery isn't taking or retaining any charge. So that's the main problem with it. To check this out was fairly simple, but it was interesting to find out what was going on here. The idea of this little module is to prevent you turning the torch on while it's under charge. So when you charge it, when you plug the charging cable into it, then what you'll find is that this relay switches the control circuit of the switch and the fuse out of circuit, and it just leaves the the input DC going directly to the battery to charge it. In other words, you can't turn the torch on when it's under charge. It's a changeover relay. When you plug it in, you hear click, and it open circuits the control circuitry on it. When you unplug it, then it goes back to its normal operating system, and you can turn the torch on and off. That's if the battery would work, of course. So let's have a quick look now at this circuit of this module. It took a little while to actually sort this out. Strangely enough, I was surprised. I thought it would be very simple just to reverse engineer that little printed circuit board, but it wasn't that simple. Once I realized that this relay had a changeover contact in it. Basically, your 7 volts DC comes in here. You've got a little protection diode in series with the relay, and basically when you plug the charging circuit in, that energizes this coil of the relay straight through there. These normally open contacts, normally closed contacts open, but they close on this contact, and that makes a circuit from DC right through to the positive of the battery, and the negative is connected to the battery anyway. So then the battery is being charged via the DC adapter charger. Once the battery is charged, it's indicated on the charger by a red light going off. Once that happens, then your battery is fully charged. When you want to use the torch, you unplug this socket. That removes the DC from the relay. This contact reverts to a normally closed position with a de-energized relay, and what happens then is you've got your battery through the normally closed contacts of the relay to your on-off switch, which we showed you earlier. That goes through a fuse, inline fuse, to the bulb, and the bulb back to the negative of the battery. So when you turn that on, you complete a circuit and your torch lights up. It's a nifty little circuit, and achieves its aim of not allowing you to turn the torch on when it's under charge. So very simple, and checked all that out, and the relay clicks in and out with no problem. All the other components are okay except the battery. So we can say the bulb is good, we can say the fuse is good, the switch is good, the relay is good, the diode's good, but we have a question mark over the battery. Now what I've done is gone online and ordered a new battery for it, and so we'll have a look at that just now. So the whole thing is powered by this John Light rechargeable lead acid battery, and I've ordered one of those from eBay, and amazingly it's going to be with me tomorrow, which is brilliant. Only took 4 days, and believe it or not, the postage was free, and the cost of this is just amazing really. I thought I would be paying 20 odd pounds for it. In actual fact, it was just under £11, so that's very good. Now waiting for that to arrive so we can fit this and confirm that our diagnosis of this Duff torch is that the battery had failed. So that's it really. Times the internet amazes you, doesn't it? And my battery, which was scheduled to come tomorrow, is in actual fact arrived now. So anticipations while I open it. This is always an exciting but at the same time worrying part. It looks good. It looks about the right size. Oh my goodness. There it is. It's the 6 volt 4.5 ampere hour battery, and comparing it with the other one, it's absolutely smack on the right size. So really pleased with that battery, and heck, I'm now going to have to just jury rig it to make sure that it is working. So I'm going to do that now. Right, I've connected the actual light, the bulb. Make sure all that's done. Connection from the switch to the bulb housing, the outer, the negative I'm going to put on first. That's going to go there. Oh dear, I'm always a bit worried about this sort of stuff. So let me just check. I've got the positive coming from there through the switch to there, and the positive is going to go on there through the fuse. Just check a voltage now to make sure that we've got voltages available. Yeah, 7 volts on there. So if I now switch this on, the light should come. Ready for bangs? Yes! And it's working. I'm really pleased with that. Obviously it's an uncharged battery. Now I'm going to plug in the charger. Charger's plugged in, the red light's off on that, and now when I try to turn it on, nothing happens. And if I check here, I've got 6.3 volts coming from the charger charging the battery. Well, I would say that was a success, and it all seems to be working as my circuit diagram predicted it would. So quite pleased with that, and put that down as a successful repair, and unplug that again. The relay clicks to its neutral position, and the light is working. Wow. Now all it remains is to disassemble this and reassemble everything in the torch body, which we will do shortly. Now going to put all this together into this empty torch. The first thing that needs to go in, if we move all this away, is the battery, and just going to fit that in now. So that goes in, but we need to make it a bit more stable than that. So I'm going to put on some of these little rubber things on the side, so it doesn't rock about quite as much in there. These black ones on just to pad it out a bit so it doesn't wobble about too much on the inside. I think that might do it. Let's try that. That's almost perfect, so there's no rocking of the battery now inside. The next job is to start assembling this assembly, and to do that we need to find, oops, there we go. And to do that we need to first of all put this little device, the relay device and the charger, actually back in to this assembly, like that, so that the holes line up. Now the annoying thing is this little cable here, because where it's positioned, you can't actually connect that while this is connected. So I'm going to take this one off again so that we can put the lower assembly in without a problem with the light assembly at the top. Take that out, make sure we keep that safe. So I'm going to put that back in its little screw bucket, and now we can start putting this in. I might have to move the position of the camera slightly so you can see what's happening here. A little bit of a fiddle to fit all that in. The main one is not trapping any of the wires when you put the top in. It's a bit frustrating because you can see all the wires but you can't get at them. So anyway, that's done and the fuse is well out the way. So that's the bottom fitted, and I have checked the switch mechanism before I actually put the top on to see that it's all delivering the right power, and also that the mains, the DC plug isolates the power when you plug it in. So that's all ready to put the top on there. Okay, so that's the top screwed on. Move some of this out of the way, and that's it, finished. The proof in the pudding now, I suppose, is to switch it on, and there we go. That's it turned on, and it's working. Off, on, plug the turn it off, plug the charging cable in when we find it, plug the charging cable in here, try to turn it on, and nothing, and the thing is charging. So quite pleased with all that. Unplug it, turn it on, and it's working perfectly. So there we are. Not at its full brightness because the battery is not fully charged, but anyway, there's the torch fixed. Well, that's it for this video. It's gone on a bit, but it's amazing how many directions just looking at one single torch marked in candle power can lead you. And I hope you learned a little bit about candle power. I'm just going to put up in a few minutes some of the formula and some of the things we've talked about, just as a slide. But basically the torch is working, and I'm quite happy with that. A new battery, the total cost just about £12, and I hope the lady that it belongs to is going to be very, very happy. As always, before I end this video, I'm going to say thank you very much to all my subscribers, and thank you very much to all those people who watch my videos. I'm very appreciative of that. Before I do it, we have to be reminded of this one, And if I switch this on, mind your eyes, I'm not going to shine it right into the lens. Yes, I'm now illuminated. Oh my goodness me, that's scary. I'm now illuminated by 2 million candle power. Wow, what a difference, and what a bit of a scary difference. I'm going to turn this off now. So I'm going to extinguish this big one, huge thing here, turn that off, and I'm also going to extinguish, when my eyes get adjusted again and my lens get adjusted again, my single candle power. Thank you for watching this video. Thank you to all my viewers and subscribers. And as always, take care. Don't be afraid of the dark.